Welcome to this video on ICS Security. This is a two-part video. In this part one, we will be discussing on industrial control system. We will try to get a good understanding of what industrial control system is, what are different terms in it, what is the basic principle on which the industrial control system operates, what is OT system, what role IT system plays within an ICS environment. And then once we have built a good understanding of industrial control system, then we will discuss about security of the industrial control system in the second part. So the video is intended for those IT folks who are working with an industrial environment, who are working within a manufacturing company, people who are working with a typical IT organization that just deals with information and virtual processes. They can say bye bye to this video because security in an IT organization is a lot different than security within a manufacturing company. And the industrial control system exists only in the industries, only in the manufacturing companies. It does not exist within a typical IT organization that is dealing just with information. The industrial control system, the industries, the manufacturing, they are not just dealing with information, they are dealing with information plus some physical processes that are producing some physical parts. And there are these physical processes involved, like on a factory floor, you would see assembly lines, you would see cranes, you would see forklifts, you would see industrial robots moving here and there, and you will see workers who are working within this environment. And if due to security, if you implement a strong security control which kind of messes this environment and which kind of malfunctions these devices, then human lives can be lost. So that is the reason safety is of paramount importance in an ICS environment, and the whole ICS environment operates on the principle of safety first and security later. But in an IT environment, it is security first, and you know it's a balance between security and availability. There is no safety at cost. I mean, what could happen if in an IT organization you implement a wrong security control? At the most, you will end up causing the downtime, end up closing the company, end up giving a big financial loss to the company. That's it. But a loss of human life is very rare within an IT organization. So that is the reason in an ISIS environment, things are very different. So if you're an IT person, if you're a IT security professional who's working with the ICS environment, who is working in an industrial environment, manufacturing environment, then you can understand the real pain of how implementing security is difficult within ICS, because the ICS is dealing with these physical processes of you know producing something, and the loss of human life can be a big price for a firm. And also the availability is also very important. In an ISIS environment, you're producing some product, you're producing some service. Example, say a power generation company, a water generation company. If you end up messing with the physical processes and causing a downtime, then the power generation to big cities would stop. Imagine some hospitals missing, facing a power outage. There will be loss of human lives there as well. So the ISIS environment, it deals with physical processes that are governing the real life world, that can have a direct and bigger impact on the real life world, on human life. And that is the reason security in an ISIS environment is very different. And that was the intention of creating this video, where if you're an IT professional, if you're a security professional who is working with manufacturing industry, who is working with industrial environment, you have recently moved, or you have moved in the past from an IT organization to a manufacturing company, then getting a good understanding on the ICS system, on some of the terms used in ICS environment, and how IT system is integrating and helping the ICS system to run, will help you to understand how to design your security strategy for the ICS environment. So, a little bit about the definition of the industrial control system. The industrial control system, as the name suggests, it's a control system for industries. It's a control system which is controlling the information technology, that is involved in the physical processes that are running on the factory floor. So on the factory floor, you, as I said earlier, you have these conveyor belts, you have these assembly lines, you have these forklifts, you have these cranes that are running, picking up parts and keeping it somewhere else. You have these industrial robots, you have these robotic arms which are drilling maybe holes into the cabinets, which are maybe drilling or which are hammering nails into the cabinets. So all these different physical processes that are running on a factory floor to produce some product, to produce some service, you will be implementing industrial control system to control these physical processes. And industrial control system is an umbrella term covering a number of different technologies which were developed independently by different industries to solve different problems. Uh, but to simplify the understanding, we will discuss some common technologies and some common devices that you would see in a typical industrial control environment. So, as I said, that industrial control system is an umbrella term which includes these two technologies, that is DCS and SCADA. So, SCADA and DCS, we will discuss them in detail on the next slides. These are the two technologies which fall under ICS, and then there are these devices such as PLCs, RTUs, sensors, actuators, HMIs, data historians. These are some of the most common devices that you will find in an ICS environment. So this is not an exhaustive, complete list of devices that are found in ICS environment, but these are some of the most common type of devices that you will see within an industrial control system. What is the definition of a system? A system is a set of things that are put together to do something. So these are the set of things that are put together to do something. These technologies, these two technologies, these different devices, they are put together in the form of a set to do something. And that is why they form a part of, and that is why it is called an industrial control system. Now, one of the another system we will discuss is operational technology, which is OT. This is also a term that is used a lot within manufacturing environment, within manufacturing companies. OT can be said to be another system which includes the IT system and ICS system as part of it. So the ICS system and IT system can be said to be subsystem of the OT system, of the OT environment. So OT system can be said to be another umbrella term which will include ICS and IT system under it. What do you mean by IT system? So whatever networking equipment, servers, databases, software applications that will enable the ICS system to work will fall under the OT. So OT will include both ICS devices, ICS technologies, as well as the IT systems that are needed in order to make these ICS devices to talk to each other. So you will have these HMI softwares that are installed on laptops or workstations or servers which are used to control these physical processes in an IT. So that is the role that IT plays within the ICS. Let's understand the ICS system with elevator example. This is a real life example that I'm taking to give you a general understanding on the concept of ICS system. The actual ICS system within a manufacturing company, on the shop floor, on the factory floor, within a factory, is very complex. And um, without having an engineering background, it is a little engineering background of automation or PLC, and it is very difficult to understand the big complex processes within the industries. But as IT professionals, as IT security professionals who are working for these manufacturing companies, we don't need to have a very in-depth understanding. We just need to have a good to know understanding so that we can work towards securing it, because we will not be running these industrial control systems directly. They will be run by automation engineers, PLC engineers, factory workers. We are on the IT side, we are supporting this system. So just having a simplified understanding, just having a simple understanding of the dance behind the scene is enough to uh, you know to design security for the industrial control system. So that is the reason I'm using this small real life example, which will give you a good understanding of on what ICS system is, how it works. So let's say if you use an elevator to go to the fifth floor, you enter the elevator, you will find the button panel, which can be a touch screen or it will be a physical panel having the buttons which are for different floors. And then when you press one of the buttons, you are using the HMI. So HMI is the human machine interface, as the name suggests, human machine interface. That means this interface is enabling a human to talk to the machine. When you want to give certain command to a machine to for it to do something, then you will be using the HMI software. You will be using this HMI, human machine interface. So HMI, this human machine interface software, is a software that enables a human to talk to the machine. So when you press the button, say fifth floor on the elevator to take you to the fifth floor, then you are using HMI. HMI is further connected down to PLC. PLCs are programmable logic controllers. These are small computers that hold this logic of doing this activity. And they will then they are further connected to the on-field devices, that is sensors and actuators. The actuators will take the command and do some actual activity, and that is the reason they are called actuators. The sensors are something that will take some input and then display it to the HMI, give it to PLC, and then display it. So the sensor will sense on which floor you are. It will display that information on the HMI panel to you, and that is how the sensor will work. The actuator will actually take the command from the PLC to take you to the fifth floor. So the whole sequence will work like this. You use the HMI, you press the fifth floor button, the PLC will take that command and then execute that logic. It will further give that logic to the on-field device, the actuator, and then the actuator will further rotate the motor, which will then take the elevator up to the fifth floor. So this was a very simplified example, the real life example, to give you a general understanding, a general grasp on the industrial control system. So this type of system which controls the process locally in one building, in one site, it can be said to be the DCS system, distributed control system technology, because here you are controlling the physical process locally, and you are whatever the commands that you gave through the HMI, you are executing that physical process locally. You are not executing it, in a other geographical area in a different site. So the distributed system, the DCS system, will always work with physical processes that work more or less in a local area, in one site, in one plant. When there is a scene of uh, you know giving commands or controlling some physical processes which are at a different site, which are in a different plant or in a different location, which can be separated by a significant amount of distance from the controlling site, then SCADA systems will come into picture. To give you a real life example of the SCADA system, controlling satellites, launching rockets, controlling robots on Mars or maybe some other planets to which NASA is sending, they will be doing this using a SCADA system. SCADA system, along with PLCs, HMIs, sensors, actuators, it will also have these RTUs, that is remote transmission units, which will relay these commands across using maybe some radio frequency technology to a distance to the device which is far far away. So that is the example of the SCADA system. So whenever NASA is controlling um, a satellite that is orbiting in the planet far far away, around our planet, then they are doing this using the SCADA system, which will have the RTUs as well, remote transmission units as well. A distributed control system which usually works on just locally, it will not need to have a remote transition unit, because there the information is flowing just locally. You are controlling a physical process that is just happening locally. So that is the reason in a DCS you would not see a remote transition unit usually, but in a SCADA, remote transition units will be required because you will be controlling a physical process that is far far away. So that's it about this video. I hope this has given you a good understanding on what ICS is, what OT is, what are these different devices that are used, what are these different technologies that are used within the ICS environment. In part 2 of this video, we will discuss a little bit more about the ICS system, and then we will discuss on how to go about securing the ICS environment. So thank you. I will see you in the next video then.